Hello everyone, my name is Zitmir and I'm a peer mentor and EC tutor at the Engineering Learning Center. Today's video is specifically for the electrical and computer engineering majors, and it's about controlling a gearbox motor using an H-bridge motor drive and an Arduino. So to do this, we're going to first simulate it using a software called Tinkercad so that we can assure that our circuit is working fine before we start. So we'd obviously need an Arduino and a breadboard, and we'd also need a battery as a power source. So you can go ahead and add all those things in there. And the first thing we would do is we would connect the 9-volt to the ground of the 9-volt to the Arduino. And the Arduino itself can get power through your computer, so there's no need to connect it to a battery, but the motor driver needs 9 volts of electricity, so you need to connect it to a separate battery. The next thing we're going to do is go into all the components and look for the H-bridge motor driver, and it should be right here. And we're just going to go ahead and add that to our breadboard. So this is an integrated circuit, which means inside it there's a bunch of different electrical components which are going to work to kind of enable the Arduino to control a motor easily. And some of the motor drivers look a little bit different, but all of them should have about the same pins, which is the input and output pins, obviously the ground and power pins, and also the enable pins, which enable or disable all the other pins. So let's first give it some power. Let's connect the positive node of the battery to the power, and let's just also connect it right here to power 2. And then we would just need to connect our ground to the ground on the Arduino. You can connect it to the same ground or a different one, whichever is easier. And next we're going to use output 3 and 4. So what we want to do is we want to enable 3 and 4 so that we're able to use it when we need it. So we're going to connect it to one of the digital output pins, let's say D3. And we're then going to connect the input pins to the Arduino as well. So this input pin, we can set it to D4, and this one we can connect this input pin to D5. And we have to keep this in mind so that when we're writing the code, we know which pins are producing which output. And the last thing to do here is to connect it to a DC motor. You can also use a hobby gear motor. The choice of motor doesn't really matter as long as it has a positive and a negative node. It should be fine. You can use any motor. And we're going to connect it to output 3 and 4. But all of the grounds should actually be connected to ground. I believe these ones are also ground, but as long as all of them are connected to ground, it should be enough to power the motor driver. And Now that we have our circuit set up, we're going to go into code and we're going to click on text. And then we're going to create some integer variables so that we're able to set up each of these pins over and over again. So as you can recall, D3 was connected to the enables. So we can just say enable is equal to 3 and semicolon. And then we can make integer variables for the inputs. Input 3 is connected to pin number 4. So we can set that as it equals to 4. And the last one would be input 4, which is connected to pin number 5. Now we need to set up those pins to produce outputs, and we would use the pin mode function. And we would just say that we need to set up the enable pin, which is pin number 3 on the Arduino, to produce an output. And then do the same thing for all three, the other two pins. So we would change input 3, this to input 3, this to input 4, and they would all be producing an output. So the next step is that we need to set the enable pin to high when we want it to run. So let's say we want it to be on for 1000 milliseconds, which is about a second. And so we're just going to set it to enable, and it's going to be high, right? And then we can turn it off. So this code itself doesn't do anything because we're just enabling it to be able to function, but we're not telling it what to do. So you can set it so that either input 3 is negative or produces a negative output or produces a positive output. So let's say at first we want output 3 to be 5 volts. So we would just do the same thing, digital write, and we would set input 3 to be high. And then we would do the same thing with input 4, digital write, and we would set input 4 to be low. And that would go on for 1 millisecond before they would both be disabled. So let's try running our code. Oh, it looks like and this code runs for about 0.1 seconds, and then it kind of just turns off because it's disabled. So to make it run in the opposite direction, you don't have to disable it. All that needs to be done is you need to set the outputs to be the opposite of what it currently is. So input 3 would be low and input 4 would be high. So let's make it delay for about 1000 milliseconds. And once we start the simulation, at first it goes forward and then it goes backwards. And that's all for how to do it using Tinkercad. To replicate this in real life, you just have to upload your code to an Arduino and use the components to build a circuit. So I'm going to demonstrate it using the overhead camera. So I have all my components here, and I'm going to reconstruct it in real life. So I have the motor driver, and I'll just place this on the breadboard smoothly right here. And then we just need to connect the pins as we did in the simulation. So enable was connected to pin 3. Where'd it go? It's kind of hard finding the right length wires sometimes. Pin number 4 was connected to input 3, which is right here. And pin number 5 was connected to input 4, which is right here. And then we can just connect our positive and negative to the other sides of the breadboard, and then to the Arduino. And then just connect ground and connect positive 5 volts. I wasn't able to find a 9-volt battery, and the only difference it should really make is that it's going to be a bit slower when the motor runs, but it shouldn't be a problem since we're just running a motor. But if you need to turn it into an actual robot, then you're going to need a little bit more voltage, just taking into account friction and how the robot moves around and all. But for this, it should be fine, just as it is. So then we would connect these last two pins here. We can connect the power to the positive part of the breadboard. We have one more negative. This is also supposed to be ground. And then we just need to connect the outputs. So let's make this pin number 3. And let's make this other one pin number 4. So once you have all the pins connected, you can attach whatever you need to the motor, whatever you want to spin, basically. So I have this little fan, but you could also use a wheel or anything else you need to get to spin. And the last step is to plug this cable into the serial port and into the USB port of your computer. So we do that, and then we need to go back to Tinkercad, and we can just reuse the code that we used before. You can just copy it and paste it into the Arduino IDE, which is available for all students on Apps Anywhere. And once you paste it there, you just need to verify your code so that you can make sure that it's working and all. And once it tells you that it's done compiling, it works perfectly, then you can upload the code, and you'll see that once it uploads to the Arduino, the motor actually starts spinning. So the last thing I want to mention is that although in this design I only attached a single motor, you can actually control 2 motors using one H-bridge drive. And if you connect multiple H-bridge drives to the Arduino, then you can control as many motors as you need. So you can also set it up with like sensors and with other electronics. There's so many possibilities with this technology, and I encourage all of you to try and explore it a little bit further.